So welcome to lecture 13 of our CS2 classes. And so up until now, what we have looked at was something about loss distribution. Then we had a look at its moments and the way we can figure out which distribution and its parameters will fit best the data that we have at hand, which will eventually help us to predict the loss distribution for the next year, which will again help us to have a certain idea of how much of a reserve we as a company need to keep so as to meet the certain requirements or the potential liabilities that can be incurred by the company in the following year or in the following years. So today what we are going to have a look at, and we also looked at the reinsurance aspects of all of these things and different kinds of treaties which can be possible. And so today we are going to have a look at risk models. So this was all about, when we already knew that the claim was going to incur, and we were just having a look at the macro aspect of modeling. So now when I'm talking about risk modeling, what we will be doing is we will study some techniques which will be used to model as well as measure a particular risk associated with any portfolio of the contracts. So if you're an insurance company, we'll be looking at the insurance contracts. And for a company, the number of risks associated with any particular portfolio, that is what we will try to model and measure within this chapter that we're going to start today. So there can be various different methods and techniques again to model the claims that incur. So first of all, I want to put forth this question to each one of you, and I want answers from everyone. What aspects do you think you will take into consideration if you were to model the claims for any insurance company?
The age of the holder.
Okay, let me write. The age of the holder.
His income.
Gender of the holder.
This is life insurance we're talking about, right?
You can talk about any insurance. Just give me the name and I'll just write it in front of it. So I had someone say gender, someone said income.
The amount of the claims.
The amount of claims. Okay, that looks something different.
So
Lifestyle.
Dropout percentage, like the people who surrender.
Okay.
If the person smokes or doesn't smoke alcohol or not that.
Life expectancy, basically.
Yeah, mortality rate. Anything else? So let me ask you guys one question. Can all of these things which I have written in pink and maybe more, not limited to this, be accounted within this? So I know that the amount of claim which I will incur as an insurance company will depend on these things, right? The amount of claim. Do you guys agree with this?
Yes, ma'am.
Right? And again, dropout percentage is something really different, which we don't have to look at when we are trying to model the claims. It is maybe when we are trying to model particular profit, let's say, at that time we'll have to look at how many people do, consider getting their cover again, reinsured for the next year, and how many of them do drop out. So again, we know that, generally the covers are only for 1 year. And if an insurer wishes, they can renew the cover or they take the insurance policy. So now what we are looking at, all these variables that we have determine the amount of the claims that we as a company can incur. And what is the another thing about claims that I as a company should be worried about? One is the amount of claims, and the second is
Premiums?
Premiums, yes. So premiums will again, be fixed because right when we sign an insurance contract with any particular customer, we have a fixed set of premium rules, right, defined for each year and each action taken by the, right? So it is fixed, yeah. Anything else?
And
Number.
by amount of claims, I meant the monetary amount, like the amount that the insurance company will be liable to pay out. Okay.
Yeah. I do mean it in the same way. Yeah, the monetary, yeah. Anything else?
Total
The
number of
amount.
claims, ma'am.
Total?
Number of claims.
Total number of claims, exactly. So because we also have to look at, the number of claims we as a company are incurring. So sometimes we can have a large number of claims with maybe smaller amount of claims, or sometimes we can have a smaller bunch of claims with a very higher claim amount. So you cannot really specify a particular loss which you might potentially incur just on the basis of either the number of claims or on the basis of amount of claims. You
The
have to
type
look
of
at,
the claim?
yes, the type of the claim is also very important. But again, I would, categorize the type of the claim after this. So this is a very generalized version I'm talking about right now. The type of the claim we will have a look at. And again, what are the general types of we can have? What are the general types of claims we can have? What are the broad two categories of insurance? Anyone?
Life insurance and general insurance.
Exactly, Prajakta. So we have life insurance and we have general insurance. So if I'm talking about the number of claims now, how many number of claims in a life insurance can occur at max?
One.
One, right? And in general, we don't know. So as many, right? There is no limit to it. So basically you can write multiple claims as well. Yeah. So again, we do have to look at the type of policy that we have in place, and that will determine the number of claims. So if you are looking at a life insurance policy, you know for sure that there is only a maximum number of claim, one that can incur anytime. And the next is general insurance, wherein you can have multiple amount of claims and multiple number of claims. So this is just a broad overview of the types of insurance you can have. But again, can there be different types of insurance based on the timing of the insurance? So based on the timing of the contract, I would say.
Immediately Yes. payable and paid at the end of Whole the year. life term insurance. All that.
Yeah, exactly. So you can have some short-term contracts like motor insurance, or sometimes you also have group life insurance, and sometimes you can also have 1 year term assurance policies and all this sort of stuff. But again, that is, I mean, at the end, in this chapter, what we will do is we will ignore the types of insurance, types of claims that we are having a look at, and will instead focus more on the feature which fits into the criteria that I will be defining within a moment. So again, okay, the one, yeah.
Ma'am, what do you mean by like total number of claims in life insurance will be one? I mean, what does that mean?
Oh, so what do you understand by life insurance, Anvaya? Whenever I'm talking about the life insurance, a person can die only once, right?
Oh, okay, yeah.
So the claimant could be only be one
Okay,
at
yeah,
max.
okay, yeah, got it.
All right. Yeah, perfect. Thank you very much for asking that question, though. Okay, so within this chapter, we are defining, or maybe I can say we are restricting our modeling to short-term contracts. So we'll only be looking at certain, not very longer term contracts, but just short-term contracts. But yeah, this is again just, a technicality, and a few things will change, but I think the idea remains the same. And to start with, we have to have a look at, a basic model. Oh, and even before we have a look at the basic model, let me ask you guys one more question. What risks do you think you can insure against? What kind of risks do you think anyone can insure against?
Fire.
Yes. So if you talk about the things you can insure in terms of examples, the list can go on forever, right? So we have to determine
Like
certain features.
certain risks and uncertain risks. So like life insurance is like the claim will surely come because a person is definitely going to die. But in case of fire and all, it is like, uncertain that the event might happen or might not happen.
So that I would agree. And again, in terms of life insurance, you can have certain policies which only cover, let's say, for 100 years or for the next 80 years, and you might not die. So the claim might not incur, but again, there will be defined rules in, what happens in those terms. But we know that there is a maximum chance that you will die. No one will, maybe you can, but yeah, maybe you won't. So
Ma'am, there are
that's,
different kinds of insurances that at the end of a life insurance, even if you don't die and you survive to the term, you still get a claim amount.
yeah, so you actually get a promised endowment, which will be, calculated. Yeah, that's there. So they'll pay you the rest of the amount. Yes. I think HDFC has such a policy. Even LIC does. Yeah, so again, we haven't yet answered the question, right? What kind of risks can be insured? So the basic criteria for any risk to be insured is that we should be able to summarize that risk in terms of numbers. So it shouldn't be something which is intangible. Let's say you risk against your goodwill. So, people do have in accounting a way to measure the goodwill, but again, you cannot necessarily, insure against your goodwill because it is not reasonably quantifiable in nature. And again, the prior thing that should be, present in each and every risks that a person insures is that there should be an interest of the insurer, of the policyholder within the risk that they are insuring for or against. So they should care basically about their own life if they are if they are taking out a life insurance. So that's it. And again, so in terms of these chapters, we'll be having some certain assumptions. So again, I would say just to remind ourselves, there should be, let's say if we try to insure against something which is not quantifiable, then what can happen? Why do you think those kind of risks we cannot insure against? Anyone? So I'm trying to ask the question, why do we think that any risk should always be, quantifiable in nature for it to be insurable?
So that the basic amount can be decided.
Exactly right. So whenever it comes, so let's say if you incur a claim and that risk is not reasonably quantified, then there will be ambiguity, right, in terms of the stance of the claim amount that the policyholder thinks he should get and the insurance company thinks they owe, right? So there should be a clear stance with the claim amount that is to be reimbursed or to be incurred by the company. So this should be clear. And again, you know, whenever you're trying to insure, let's say, anything. So if you already possess a certain heart disease or something which puts you already on the verge of dying, then you cannot go to an insurance company and say that, you know, I want to insure my life. So certain kind of risks. So the risk that you are going to insure against should have a very small probability of happening. But again, it varies from companies to companies and their policies to policies and again contracts to contracts. But again, in general, the probability should be relatively similar. And again, you know, if you are an insurance company, you would never want all of your risks to be codependent. So let us say if people are insuring against their house, I mean, I'm talking about a very small economy, let's say. I mean, there is only one company and they only insure within a particular village. So let's say if there's a flood and the whole village is just, you know, in crisis. So we know that the insurance company will be burdened because now their risks are dependent on that one flood. So if one particular person is going to claim amount, there is a higher chance that the another person would also go and claim, right? So again, we desire a low correlation between the risks that you want to insure. But again, we don't say that we want zero correlation because that's outright not possible. And at least in this century, we know that things are dependent on each other. And basically, you have this butterfly effect going on where if a butterfly flaps its wing, let's say in Karnataka, then there can be a flood caused just by that flap of wing in US. So you cannot necessarily guarantee. But again, you as a company, you want to try to minimize the correlation among the risks that you're trying to incorporate within your company, or let's say within a portfolio as well. So, you know, generally people do talk about, even when you're investing in stock market, people do talk about this, right? That your portfolio should be well diversified, and you have these theories of CAPM and efficient market hypothesis where they will dictate that, you know, it is in the interest of investors if you have a diversified portfolio so that stock, let's say, goes very low, then it can be balanced out with another stock which might go high. So again, that depends on the kind of portfolio you have. So yeah, if you have a well diversified portfolio, then you are on a balance. But again, if you are a risk taker, then you might not really believe in those theories. So yeah, I mean, that's it. And again, you know, has anyone heard of adverse selection? Anyone?
Yes, ma'am. Is it something like, uh, so if we take in case of an insurance company, so like they end up selecting the bad lot only of the whole lot, like the more,
Yeah, that is,
yeah, like the
yeah,
more, the people who are more prone to that particular risk.
exactly. So I think the very famous example to explain adverse selection is about the car market. So let's say if I am into, you know, a second-hand car selling market. So what I have to do is, so let's say if all of you guys, you are the customers, you all want to sell your second-hand car, and I am the investor, let's say, and I am the buyer, and I want to buy one of these cars. So what will I have a look at? So again, all of you guys being the sellers, you will try to, you know, portray that your car is good enough, right? And I will try to see, I will have to maybe see through, but again, how much can I see through your car? You yourself know the actual condition of your second-hand car which you're trying to sell. So generally what happens is people who market their car, let's say second-hand car, at a higher value, what will I think of it? Can anyone be in my shoes right now and tell me, if one of you guys is marketing and trying to sell your second-hand car at a higher price than rest of the others, what will I think of that car?
That it has a good quality.
Yeah, that it has a good quality. What about others? What do you guys think I will think?
That it was better maintained than the other ones.
Yeah. What about others? Almost. Yeah. Go on.
The same as Nisha said.
I couldn't hear you. There was a bit of noise in the background.
The same as Isha said.
Okay, okay. All right. What about others? Do you have anything to add?
The features of the car are good compared to others.
All right, right. So the very first thing that comes to each one of our web of you wanted to add something?
Any
Go.
additional accessories or something like that?
Okay, okay, yeah. So again, what happens is, the very first thing that comes to my mind is that maybe the car is in any ways better than the rest of the cars, right? So you guys do know this information, right? You guys do understand that if you price your car at a higher range than the others, then you are in a way signaling to me that your car is better than the rest of them, right? If you believe that I think if a car is priced at a higher range, then it has to be good. So what happens is, even the cars which are not as good as maybe compared to the other cars, so these sellers will understand the psychology of the market and they will try to price their cars at a higher range. So for me, now it's a confusion to see which one of these sellers cars is actually good, because the price no longer dictates me anything and the psychology has already been taken into account. So sometimes this happens in the market. And the other thing that generally happens is, let us say, it's actually called moral hazard. So the thing that we talked about now, there is a theory, the market of lemons. It's by Eckleberg. I don't actually remember the guy's name, but yeah, it's called market of lemons. So it's like you have to figure out which ones are good and which one's just the lemon. So I was talking about adverse selection. And the second thing that generally comes to mind is moral hazard. Has anyone heard of this term, moral hazard?
Yes, ma'am. So this one is like after taking out the insurance, people will behave in a careless way because they
Exactly,
already
right?
have something insured.
Yeah, so they already have a guarantee that if something goes bad, they will get their claim amount reimbursed from the insurance company. So they behave not in a responsible manner, and thus it increases the chance of them claiming the actual amount or the risk which they have quantified actually occurring. So this again, this is actually a bit of an unfair practice. But again, insurance companies do try to monitor these moral hazard practices, but how much they can monitor? That's a question, and it can never be answered because people are smart enough always. So these are just, certain things that I think everyone should know about. Whenever, I mean, these theories are not only related to insurance market or the actuarial rules, but also in terms of general financial economic theories. And it's really interesting. So if anyone finds this interesting, you can actually read up a lot about these. And there's something else known as, a principal agent problem. So let's say if I'm talking about a principal agent problem, Isha, do you know about this as well?
I feel like I've read it, but I can't really remember.
Oh, so just to give you guys, a very simple example, let us say there is a company and you have 5 workers, let's say, or let's say you have 500 workers and there's only one manager. So that manager now has to decide if he should go on a monitoring round to check whether the workers are working or not. So there is a cost for him to get up from his chair and roam around and have a check at all the 500 agents. So here, the principal is the manager and the agent are the workers working under him. So 500 agents and one principal. So he has to decide whether he should monitor them or not. So again, he has to take into consideration what workers are thinking. So for workers, they can, try to not work if they think that the manager is not going to monitor. And they can maybe try to work if they think or if they have a hint that the principal is going to monitor them. So there is this underlying cost in monitoring and not monitoring. And there is another underlying cost in doing the work and not doing the work. So this is like a short-sighted thing. But yeah, I think it's something which is really interesting. So the problem is for the worker to whether work or not, depending on if the principal monitors or not. And the problem for the principal is whether to monitor or not, depending on whether the workers are working or not. So it's essentially known as principal agent problem. So yeah, that is just a very simple example. But again, we don't have these. So that was just a bit for someone who would like to explore beyond. Okay, so for this chapter, let us start with the chapter now. So our chapter is known as risk models. Okay, so why do I have to model something in the first place? Can anyone tell me? Why do I need to model things?
To generalize it.
Which? What did you say, Mihir?
To generalize it.
To generalize it. Okay, yeah, that's a very good reason. And?
So that
To
we
draw
can apply it to the
inferences.
same.
Okay, we can have one person speaking at the one time. Savri, can you go first?
So once we generalize, we can maybe use the same model to other claims also if we are generalizing it. So you can basically use it again and again.
Only if the certain assumptions that we fix for a particular model also? Yeah, all right. Yes, Vaibhav?
To have a plan in action, basically, to follow a certain thing.
Yes. Isha?
To draw inferences from it.
Yeah, to draw inferences from it, right? But again, the very basic thing that we want is to know something, basically to know something about the future, right? And why do we have to model it? Because we don't know future for certain. It is uncertain, right? It is random, anything can happen. And we want to take into all those possibilities and try to project our best so that we can profit maximum, right? So, okay. So whenever I'm talking about uncertainty, that is what leads me to model anything, right? If things would have been certain, I mean, I would still model, but again, those won't necessarily be this complex, right? I mean, it would be very deterministic and everything will be known. So again, the inference and all these things, you won't even need basically these complex risk models and everything else. So let us say if now I am the insurer company, so I want to look at the certain uncertain things that affect me as a company and my profitability. What do you think those will be? So those will just be, in short, the amount of claims and the number of claims. So these are the two sources of variability that any model, any risk model pertaining to insurance has to take into consideration. So the number of claims, we define the number of claims by a random variable n, and we define the amount of claims by a random variable x. So again, now if I have to determine the aggregate loss that I as an insurance company can incur in terms of these two uncertainties, how can I do that? Anyone? So let us say I define my aggregate loss as S. This is my aggregate loss that I incur as a company. So now what I want to do is, I want to define my total loss using the number of claims and the amount of claims that I can incur as a company. So how can I do that? Anyone?
The loss would be expected minus the actual, right?
The expected minus the actual. What expected and what actual?
Amount. The expected amount of claims and the actual amount of claims.
So, okay, wouldn't the aggregate loss be the actual amount of claims, because that is what you will be paying to some person, right? Why do you think that should be expected minus the actual? So I'm actually talking about, the loss as a company. कितना पैसा मुझे पे करना पड़ेगा अगले साल अगर मुझे claims आता है तो?
And I think
Okay.
Vanchita meant it like actual profit and loss, like what we are prepared for
Yes,
and what we
yes.
actually have to give.
Yeah.
Okay. Yeah. So, yeah, that loss I'm not talking about here. That is not the loss I'm talking about here. We're talking about the aggregate loss. But yeah, that's a good point. Yeah, so how do you guys think I can summarize my aggregate loss? So I think if loss confuses, we can also write this thing as aggregate total claims. All right. So this is what I'm looking at. The aggregate total claims. So I know the number of claims is n and the amount of claim is x. And these are the random variables. So I want to define my aggregate loss in terms of my aggregate total claims, which I have to incur as
N
an
into
insurer.
X.
N into X. So when you say N into X, so if you say that this should be N into X, are there any implicit assumptions that you are assuming?
Actually, like, is this like in a particular year or something? Because all of the claims won't come at a single time, right?
Yeah. How will that affect what you just said?
So the number of claims will be defined as the number of claims in a year.
Okay, so let's say I define my N as the number of claims in a year. So do you think S should be defined as such? What do others think of this?
But the X amount will also be like subjective to each policy, right? So
Exactly.
probably something like N1X1 plus N2X2, something like that.
Yeah. That's actually it makes much more sense, right? So N1X1 plus N2X2. So if you're talking about N1X1, N2X2, this is a particular amount of claim And what you are trying to do here is measure how many times that one particular amount you have incurred for a claim, right? Because that is what will be N1, right?
Yes, right.
And according to you, N1, N2, and all of this stuff should add up to N, right? So yeah, that is indeed correct. Does anyone else think of something else to do? Okay, so Isha, that was really a very good answer and indeed a correct one, I would say. So for this chapter, what we are going to do is we are going to define our aggregate loss as a summation for excise where I goes from 1 to n. So this is actually, in a similar essence as this, but this is a more compact way and a more efficient way to just write the same thing that Isha just dictated. So my S would be a summation of all the amounts that I incur, and then again I have N. So basically it will be X1 plus X2 till Xn, right? Why? Because what I'm just doing here is simply adding up all the claim amounts that I incur. So I know if I incur N claims, if I incur capital N claims, then I will have X1, X2, X3 up until Xn. And what does my X represent? The amount of claim 1, the amount of claim 2, the amount of claim 3, and the amount of nth claim, right? So in a way, if I add all of these, I should get S, right? Does everyone understand what I just did?
Yes.
And what about others?
Yes.
All right. And okay, so let us say if my N is 0. So now if I incur no claims, then what will be the value for S?
0.
Exactly, right? It has to be 0 because if I incur no claims, basically there's nothing happening. So there is no loss. So this is just, a way to write. And again, now what we have to look at is, we have a bit of a problem here, right? Because if I want to model my S, if I want to model my aggregate loss, I have to look at a summation of I going from 1 to n. And now my n is a random variable itself because I don't know what the value of n is. And my xi's, they are also a random, my x is also a random variable. I don't know what my amount of claims are. So the distribution that our S will have is known as a compound distribution, and that will denote by Gx. So again, we'll have a look at that later. But first of all, let us try to consider that we have a portfolio where we have small n individual contracts. And again, S is the aggregate loss of the portfolio within a stipulated time period, which can be 1 year or a quarter or 2 years or 10 years, anything the way you define it to be. So generally, we define all of the risks that you can see in 2 types. One is individual risk. So what happens in individual risk is, so the first type is individual risk. And here you will be looking at, a loss from each individual contract. Thus the name individual risk. So let's say if I'm writing my SN, it will be written as X1 plus X2 up until X small n. So over here, each of these X's represent the loss amount from that particular contract. So my X1 here is the loss amount from first contract. And again, my n here, so the small n which I have is the number of contracts within a portfolio, right? So I'm looking at one portfolio. So this will just be the number of contracts within a portfolio. So if you see, I wrote a small n, right? Because what happens in individual risk is you know the number of contracts that there are within a portfolio. So we know that, this small n is a fixed number. So this is a fixed number and not a random variable. So this is how you will categorize individual risk models. But whenever it comes to collective risk models, which is the separate kind of so the next type of risk that you can have is collective risk. Would anyone want to guess what might be happening here? So here what happens is,
Random variable.
yeah, exactly. Here n will remain a random variable. So we have S capital N and it will just be x1 plus x2 up until x capital N. So here again, this n will represent the number of losses or the number of payments you do. So there is a bit of a difference. So what's happening is within the individual risk, you already knew that, this X1 is the loss pertaining to my first contract. But what happens in collective risk is each loss may or may not correspond to a unique contract. So this loss and this loss might have a bit of first contract and a bit of first contract. So you can never say that, X1 is just the loss from my first contract. That is only with the individual risk models. And now if you see, what's happening in collective risk is that this collective aggregate loss is defined in terms of, again, our two random variables, the frequency of the claims and the severity of the claims. Frequency denoted by capital N and severity denoted by capital X as the random variable. So we will have two distributions within a particular model. So one will be the distribution related to the frequency of the claims. Would anyone want to guess what kind of distribution?
Yeah. Can you please just repeat why n is a random variable here and not a random variable in individual risk?
Oh no, so that is how it is defined. It's like if you have a random variable, then it is defined as a collective risk. And if you don't, if you know the number of policies, the number of contracts you have within a portfolio, then it classifies as an individual risk, because that is what I'm explaining right now. So what happens is, if you have a collective risk model, let's say, you don't know the number of claims you will have, the number of losses you might incur, right? So you will have to look at two distributions. One will be pertaining to N and the other will be pertaining to X. But if you already know the number of contracts that you have within a portfolio, then you only have to care about the amount of each loss, right? So that is why you're only looking at one distribution here. So it's just
what are we referring to as the contracts within a portfolio?
So, okay, so here when I'm talking about a particular risk, so let's say if I'm talking about a risk, it is a collection of similar policies. And those form a contract.
So something like all of the policies that a company has under fire insurance, something like that.
Yeah, so see, within a company, you can choose to define your portfolio the way you want to be. So I would say, a portfolio is just an ensemble of individual policies, and each policy may or may not cover a particular asset. So let's say if you're talking about a fire insurance, it might be under X1 and it also might be under X2, depending on the way you categorize it. So this will become more clearer as and when we look at the examples of these both. So, but again, we aren't yet done with discussing these differences. So what happens in individual risk model is we have these claim amounts independent of each other, but they may or may not necessarily be identical. So just to give you guys an example, consider the case of life insurance. You already know, right, the number of losses that you can incur. So it's binary, right? It can either be 1 or 0. And again, the chance of each person claiming is different. So if I have, let's say, if all of you guys have insured against me and I'm a life insurance firm, so I know that I have an individual risk model to look at. You guys can either die or not die within a stipulated time period that I'm calculating this as for, right? And each of you have a different probability of dying because each of you have a different exposure and a different coverage as well. So I'm assuming that all of you are independent, but not identical. So when I'm saying not identical, that means you all might not have same distributions when it comes to predicting the chance that you might incur a claim to me as an insurance company. So let's say if I'm talking about individual risk, what I can maybe write here is that I know my X is independent, but not identical. And over here in collective risks, my X's are IID. So I define these in a way that there is a similar chance of it happening. But again, whenever I'm saying that my X's are IID, I again have to take into consideration that my X's become independent and identically distributed only if I know my N. So this is conditional upon N. So my X's are IID only if they are conditional upon N. All right. And again, so the next thing that we might have to look at is what is the relation between this N and this X? What do you guys think? Does the amount of claim depend on the number of claims? So let us say, there is inflation in the economy. So if we looked at, in the reinsurance chapter, we had a look at inflation, which might increase the claim amount that an insurance company might have to incur, right? So will that increase the number of claims? Not necessarily, right? So that is why, this is just one example, but again, you guys can have other examples wherein N and X may be dependent or correlated or associated with each other. But what we are looking at are the cases where N and X are independent of each other. And again, so it's, so, just to remind ourselves, there can be two main categories of the risks that we might have to look at. One is individual risk and the other is collective risk. So whenever we know the number of contracts that we have within a particular portfolio, which is just, a collection of similar policies. So when I'm talking about a contract, it represents a particular policy which a particular policyholder has signed with me. So that forms a contract. So the number of policies I have sold to other people. And if those are known, that if the number is known to me, then I would categorize it as individual risk. And again, there should be one thing that they satisfy is that all the amounts should be independent and not identical. And in collective risk, I again don't know the number of losses that I might incur. And a very important thing is that each of these X's may or may not correspond to a unique contract. So a contract I might have signed, within a contract, a number of risks, and those might be distributed among these X's. So you can never know. But again, here we know that my amount, the severity of the claims will be independent and identically distributed if I know the number of losses I have incurred. And I also assume that the number of claims and the amount of losses, those will be independent of each other. Oh, and again, so just to give you guys a perspective, an individual risk can also be classified as a collective risk. So what happens is, only if, so these individual risks can come under collective risks as well, but they have to satisfy some certain conditions, right? So when I'm saying that, this n is known to me, sorry, this n is known to me here, and here I do not know the n. So only if this is identical as well, then you might classify this as collective risk. But again, we don't necessarily look at those because it is just, a particular instance where individual risks can also be classified as collective risk. But again, you have to look at the conditional distribution then, because you assume that you know this n. So, we won't necessarily be looking at those kind of things. So this is just, a gist of the kinds of risks that we can have a look at. We will be having a look at. So again, so we'll start with collective risk models. So does anyone have any questions in regards to this slide?
No, ma'am.
What about others? So again, I think it might be a little vague in terms of, digesting, like, or maybe, understanding what kind of risks you will classify as individual or collective. But as and when we'll move forward with the chapter and we'll solve some sums and all, you will get to know, and it will be very clear as in when, it's just, so let's say if you're reading a question wherein it defines the number of contracts or the number of policies that you have insured, then you know that it is an individual risk model. And if it does not, then you know that it's a collective risk model. This is just one very basic condition to classify the risks on. So let us move forward with the main assumptions that we will rest the whole chapter upon. So we're talking about assumptions here. So my first assumption will be that, all of my x's are IID random variables. So my first assumption is that all of my xi's, and I can go in theory from 1 till infinity, are IID random variables. So whenever I write a curly bracket, it means that I've defined a sequence. So what I'm saying is that this sequence is a random variable and these are IID. And in words, I can maybe write that, it just says that my claim amounts are independent. So I have independent claim amounts and identical as well. And second assumption that I will make is that my n, which is the frequency of the claims, is independent of its severity. So this is basically independent of xi's. So if you guys have to think in terms of statistics, so the way I wrote here for this first assumption was that it says that these are independent claim amounts, right? So I've used, this will in a way help me to do some statistical analysis. So what do you guys think this sentence says about the claims and the distribution of claims, to be precise? what will happen to the distribution of claims if I say that my n is independent of my xi's? So do you guys remember the graph that I drew? So just a simple graph. We had this and we had a look at this. So this was the amount of claims X and this was the number of claims, right? So if I say that my X is independent of N, what do you think will happen to this graph that I have drawn here? Anyone? Any guesses? So, okay, generally, whenever we draw a graph, we have a x-axis and we have a y-axis, right? What we try to look at is, if I change my x, what will happen to my y, right? Or let's say if there's a change in y, how does my x vary? So here, if I say that my n is independent of x, what will happen to the distribution that I have drawn?
It will just be a horizontal line, right?
Okay. I see. So if I draw a horizontal line, my n will be the same, whatever my x is. What does everyone else have to say about this? Do you guys think it should be a horizontal line?
If X and Y are not dependent on each other, it could be anything, right? There's no specific pattern that it has to follow.
Yeah, exactly right. It can be anything. So you cannot, I mean, see, if you have to plot the dependency, I mean, I think, so Isha, did this come from the macroeconomics that you studied?
Yes, ma'am.
I could see that. So yeah, so okay, so that was the very first thing that came to my mind when you answered this as well. So okay, what's happening here is, if I know that my x does not depend on y, then it doesn't necessarily have to be a horizontal line. It can really be anything, right? Because if I know it's not dependent, then it's not always the case that if my x is this, my n has to be this. If my x is this, my n has to be this. If my x is this, my n can be this, anything that I want it to be, or that there is in actual. So not necessarily the case that it will be a horizontal line. So, okay, the thing that I was hinting at is that if you have your number of claims independent of the size of the claims, then the distribution does not change throughout the year. So that is what it says. So basically my distribution of claims doesn't change throughout the year. So in a way, I think Isha, you did get the gist that something shouldn't be changing, but the whole distribution here does not change. So if we know, do you guys get this? So if I know that there is a higher chance of a mid-range claim occurring, and there is a very lower chance of a higher amount of claim occurring. So let's say if I divide this, okay, if these are my claim amounts and these are my claim numbers. If I know that this amount, the chance that I will incur a claim amount is Okay, so the number of claims I incur of this amount are these many. If I change this in a way to this many, then what will happen? This will not distort my graph, okay? It will maintain the distribution, the claims distribution that I have the same. It won't necessarily vary. So that is the assumption that I am making here. Does this make some sense? So it would maybe just, be something like this. It doesn't necessarily have to, not follow the distribution that it does.
Ma'am, so can we like relate this to the memory less property where the past events do not affect what will happen in the future?
Okay, so yeah, I mean, see, so that will be the case here. So whenever I'm talking about n, what kind of a distribution I will be looking at? Anyone? If I have to model the number of claims, what kind of a distribution I should be looking at? Discrete, right? It cannot be a continuous, because if I'm modeling the number of claims, it can either be 0, 1, 2, 3, right? So in general, mostly I'll be using Poisson process for this. And we know that, Poisson process has a memoryless property. So it may not be the case that, if we know that there is one claim occurred already, the chance of observing another claim would be higher or lower in some manner. You cannot really say that. But again, so again, if n follows Poisson process, then yeah, you will have memoryless property. And so again, here if we are looking at S, we know that my n will be a discrete distribution and my x will be a continuous distribution, because my claim amount can really be anything, right? Again, we'll be taking on integer values, but again, it can be anything really. So my S will be a mixture of discrete and a continuous distribution, which is why if this happens, we classify S to follow a compound distribution. We'll have a look at that just right now. So let me just write first of all that we are looking at collective risk models. So can someone remind me the way I should be writing my S here? What should be my subscript here? Capital N, right? And if my capital N is 0, then my S will be 0 again. And again, in short, I will just write my S as summation over x i's from 1 to n, where my n is a discrete and x will be some continuous thing, right? And which renders my S to follow a compound distribution, which we will derive. Okay, so first of all, we should know what things will be given to us. So the way I will be defining, okay, so what we have to figure out is this, the compound distribution of S. So let us write our compound distribution of X, S as G of X. So this is just, a probability that my S will be less than a certain number, and define f of x to be the probability that my claim will be less than a certain number, and we can define this is small x, and this will be p of n equal to small n, right? Because this is a discrete distribution. So you can maybe have a look at this or have a look at this. Yeah. So again, this is what? This is about my aggregate claims. This is just the individual claim amount. And this is the number of claims that we're looking at. So, okay. So now if I have to figure out the probability, okay, the probability distribution for my S. So let me just, maybe write it here. Okay, so what I have to figure out is this. The probability that my S will take a value less than or equal to X. So again, even before we define a probability of this, let us see what constitutes this. So if I have to see when will my S random variable be less than or equal to X, how can I summarize this as? So again, remember, whenever we are talking about N, it just represents the number of claims we have. And when I'm talking about X, it represents the amount of claims we have. So if I'm saying that my S should be less than small x, then in a way I know that my addition of all the capital X's should be less than small x, right? But again, we do not know what value our N takes. So capital N's value is unknown to us, right? Because we're looking at a collective risk model. So what do you guys think will be happening here if I have to define this set? How can I rewrite this in terms of N? Does anyone have any idea? Okay, so maybe I can just give you guys, a very simple example, maybe a hint as to what we can do. So let us say this is my population. Okay. And then I have my sample. So this is my representative sample, okay, which I will now divide. So let's say this is A, B, C, D, and this is E. Is this visible to everyone?
Yes, ma'am.
Okay. So now what I'm concerned about is how much of my population lies above this line. I mean, this is a very, crude diagram. I would say it doesn't represent any real life information. So I'm just talking about if I have to figure out how much of my population lies above this line, what will I do here? Anyone? I think this is just, a question of simple probability. Don't think in terms of complex terms. Forget about, forget about this. Forget everything. Just focus on what I've drawn here.
Maybe we'll consider the sample.
I mean, of course, you will have to consider the sample, right? Because you haven't observed the all of population. And this sample you assume is representative of this population. So yeah, when the very first step would be to identify that the number of, the amount which will lie above this line for a population will be the same, for the sample as well. So I'm looking at things which lie above this particular line in my sample.
will we have to use conditional probability?
You say? So, okay, forget if I wouldn't have given you guys this population, if I would have just drawn this sample and I have these blocks and I created this line and I'm telling you, I want the probability that I will observe a sample which will be higher than this line. What will you do? I mean, it doesn't even involve, things like conditional probability or something else. Simple probability.
Simple, just add the, like suppose we say that A, B, C are above the line, then A plus B plus C divided by the total. That is A plus B plus C plus D plus E.
Right? Makes sense. So what you are doing is, you saw, first of all the subsections within the sample which lie above that particular line, right? So in a way you considered two things, right? First was the fact that it should lie above the line, and second, the fact that it was within the sample, and then you divided it by all of the sample, right? So in a way, so now you use what we just did to write that set which I have written. So we want to figure out how to write S less than or equal to X set in terms of X and N. As well as S. Okay, so maybe what we can do is come back to this and do an example first, because I think it's easier to see when you are solving a particular example than if you just have this theory. So let me give you guys a question. So all right. So what I'm looking at right now is a compound distribution S such that, so I have my N and then I have a chart of what is the chance that my N will take a particular value. So the chance that my N will be 0 is 0.6. It will be 1 is 0.3 and it will be 2 is 0.1. So you see, right, we do not know for sure what my N will be. We just have a particular distribution for my N here. And the next thing that we know is that my Xi can either be 1 or 2. And the chance that it will be either 1 or 2 is equally probable. So now I have to figure out the distribution for S. So how do you guys think I can figure out my distribution of S? What should be the very first thing that we should do if I want to figure out the distribution for S? Anyone? So again, think of S in terms of X as well as N. Okay, let me start maybe. So the very first thing that I will look at is what are the values that my S can take. So will you guys help me to see what are the values that my S can take. So I know that my number of claims can either be 0, 1 or 2, not beyond this. And my amount of claims can only be either 1 or 2. And this is equally probable. So it's certain that I know the restriction on the values that my S can take depending on the combinations of this X and N. So will you guys help me to determine all the values that my S can take? So let me maybe start again here. So I will write 0 first of all. Why? Because if my N is 0, then I know that my S will be 0, right? Now see, if my N is 1, what do you think my S can be? If I've incurred one claim, what do you think can be the value for my aggregate claim? Anyone?
1 or 2, right?
Yeah, it can be either 1 or 2, right? You can't be sure of that. Exactly. And now if you have incurred 2 claims, what do you think can be the values for S?
1 and 1, 1 and 2, 2 and 2.
Right? So it could either be 1, 1, 2, 2, or 2, 1. So if it is 1 and 1, then what will be my S?
Ma'am, you're not audible.
Am I audible to others? Hello. Okay. Okay. Yeah. So what do you think my S will be in all of these cases? Anyone? What will be my S in this case? Hello. Am I audible?
Yes, ma'am, we can hear you.
Okay, okay. So what will be my S in this case and all of these cases as well? Shouldn't take this much of a time to answer.
2, 4, and 3.
Yeah, exactly, right? So this will be 2, this will be 4, and this will be 3. So again, if I have to write here the rest of the numbers for the values of my S, that would be 3 and 4, right? So these are all the values that my S can take, right? And this is just the distribution for it. Okay. So now again, if I have to write my S, now again, even before deriving the distribution for my S, I will have to figure out how do I define my S, right? It is what? It will be x1 plus x2, right? Am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
All right, all right. Okay, so let us now start deriving the distribution for my S. So first of all, if I have to figure out the probability that my S will be less than or equal to 0, what do you guys think I can rewrite this as? When will I observe my S to be less than or equal to 0?
One by five.
1 by 5. Why do you think it should be 1 by 5?
Um, like we have wrote this sample to be 0, 1, 2, 3, 4. So like I just did desired outcomes upon total outcomes.
Okay, so see, I would say, I mean, that was in a way, I mean, okay, let me not say that. So, okay, what did you assume when you said that probability of S less than or equal to 0 should be 1 upon 5? Did you make any assumption? Which is not given to us. Can anyone else
That
see what
probability
assumption?
S is equal to 0.
Okay, yeah, I mean, I can rewrite this as probability that S equals to 0. I mean, of course, because the probability that S less than 0 is 0, and we know that. So, I mean, I wasn't talking about this. I was talking about the assumption that was implied when you say that the probability of S that it will be 0 is 1 upon 5. So the assumption you were making is the fact that all of these outcomes are equally likely to happen. But is that the case here? We know that the chance that I will observe no claims is 0.6. For one claim it's 0.3 and for two claims it's 0.1. So you see, it's not really uniform, right? Prajakta, do you understand what I just said?
Yes, ma'am, got it.
Okay, perfect, all right. But that was a good try, and I think that was a good point to be cleared. So again, what should I be writing next? When will I observe my S as 0?
When n is 0.
Exactly right. When n is 0, so this will be equal to the probability that I will observe n as 0, which is what? 0.6. So yeah, we're done with our first chance. So let us try to figure out the next thing. The probability that my S will be less than or equal to 1. How do you guys think I can rewrite this?
Probability S equal to 0 plus probability S equal to 1.
Who was that?
Vanshika.
Exactly correct, right? So this will be the probability that my S will be 0 plus the probability that my S will be 1. Very good. And then what can I do? I will just rewrite this as 0.6, right? And now if I have to figure out what is the probability that my S will be 1, what do you guys think? How can I define my probability for S being equal to 1? So, okay, so the one thing that can really help us is to have a look at all the times when we observed S as 1. So it was here, right? Only there itself. So what do you guys think should be happening for my S to be equal to 1? How can I rewrite this as? What were the conditions satisfied here?
Probability
one
n
claim.
equal to sorry.
Yeah, go on.
So probability n equal to 1 into probability x equal to 1.
Exactly. So, okay, I will come to that next. So, the very first thing that will come to your mind is, even before multiplying them together, is and condition, right? So, only if your n is 1 and your x is also 1, then you will have observed s as 1. And now, because we have already assumed that my n and my x are independent, this can be written as probability that n will be 1 times the probability that x will be 1, which Prajakta just said. Does everyone get this?
Yes, ma'am.
Yes.
Yes, ma'am.
Right? It makes sense. So what is the chance that I will observe my n as 1 times 0.5, which is just 0.15. So in a way, if I were to rewrite this, it would be 0.6 plus 0.15, which is just 0.75. Okay, that's done. So now I have to figure out the next thing, which is the probability that I will observe my S less than or equal to 2. So again, that would just be probability of S less than or equal to 1 plus the probability that my S is equal to 2. So in a way, what you have to figure out is just this probability. So how do you guys think this would look like? So we have here and S equal to 2 there as well. How should I write this?
Probability of n equal to 1 into probability of x equal to 2.
Okay. Let's go step by step, right? So the very first step that I will write is the Yeah. So the very first step I will write is the probability that I observe my n as 1, comma, x is 2. Okay. Then what should I be writing next? Yes.
I think it will be probability of n equal to 2 and probability of x equal to 1 or 2.
X equal to 1 or 2. So, okay. If your x is equal to 1 and n is equal to 2, then 1 plus 1, 2, right? But if your x is equal to 2 and if your n is also equal to 2, then your s will become 4. Should that be the case?
No. So only for 1.
So again, the way I defined it was x1 plus x2. So my x1 will be 1 and So what I will write is that my x1 is 1 and my x2 is also 1. And what should I do here? Multiplication, addition.
Okay, I meant the same thing. I made a mistake in speaking. I meant
Okay, yeah. Yeah, all right, all right. So what should I write here? Multiplication or addition?
Addition.
Addition, right? Perfect. So, okay. So these would just be multiplications, right? Probability that my n is 1 is 0.3 and the chance that I will observe my x is 2 is 0.5 plus n will be 2 is 0.1, 0.5 square, right? So this will eventually come up to something, and this answer you will get as 0.925. Does this make sense to everyone?
Yes.
What about the rest of you guys? The class is really quiet. What happened? Hello? Is it already too much for the day?
Yes, ma'am, got it.
Thank you, Prajakta. What about others? Not in the good mood? Mihir, Vaibhav, Sabri, Anvya.
Understood, ma'am.
Got it.
Are you guys?
Yeah, ma'am.
Okay, all right. So you guys need.
Actually, ma'am, defining the S part, I found it a bit tricky, so if you can explain it again in short. Like S
Defining the
equal to 0,
S.
1, 2, 3, 4. Yeah.
Oh, this.
The
Okay.
right side corner box.
Yeah. All right. So, okay. So, see, the information that we have is this n. So, this is the number of claims that I can have, and this is x. Forget about the formulas that we have seen. Okay. Simple logic देखो क्या होता है. अगर मुझे पता है कि मेरे पास क्लेम्स आ सकते हैं कितने, एक तो 0 आएगा, एक तो 1 आएगा, एक तो 2 आएगा, राइट? ना ही 3 आ सकते हैं, ना ही 4 आ सकते हैं. So the maximum number of claims I can incur is 2. और उन्होंने ये भी बोल दिया कि क्या अमाउंट रहेगा उस क्लेम का, एक तो वो 1 रहेगा या तो वो 2 रहेगा, राइट? सो एस क्या है मेरा? एस मेरा पूरा नुकसान है, कितना हो सकता है. सो हम क्या करेंगे, हम हर चीज को देखेंगे कि मेरा ज्यादा से ज्यादा नुकसान कितना होगा और मैं नुकसान की क्या क्या वैल्यूज हो सकती है. सो अब मुझे पता है कि n could be either 0, 1 or 2. So if I consider first that my n is 0. So if my n is 0, I know for sure that my s will also be 0, right? क्योंकि x का तो कुछ रहा ही नहीं, अगर कोई क्लेम आया ही नहीं तो मेरा कोई लॉस होएगा ही नहीं. So if my n is 0, my s is also 0. Okay. The next case I look at is my 1. So if my n is equal to 1, if I incur one claim, then मेरा पूरा नुकसान कितना हो सकता है? So एक तो वो 1 रहेगा, एक तो 2 रहेगा, right? Because there can only be 2 claim amounts, 1 or 2. और अगर मैं बोल रही हूँ कि एक ही क्लेम आएगा, so एक तो वो 1 claim amount वाला आएगा, एक तो वो 2 claim amount वाला आएगा. So I write here 1 and 2 because then my S can either be 1 or 2, right? And now if I observe 2 number of claims, what are the claim amounts I can incur a loss of in aggregate? So अगर मेरे पास 2 claims आ रहे हैं, so एक तो वो 1 रहेगा दोनों भी, या तो दोनों भी 2 रहेंगे, या तो एक 1 रहेगा दूसरा 2 रहेगा, right? So अगर ये 1 रहा तो my S will be 1 plus 1 2. अगर ये 2 रहा तो my S will be 4. और अगर ये 2 1 रहा तो my S will be 3, right? Does this make sense now?
Yeah, completely.
Yeah. Any doubts anyone else has?
Ma'am, can you just explain the S probability S equal to 2 part again?
Okay, all right. So, okay, let's go from the start. When I'm writing about probability that my S will be less than or equal to 0, less than 0 होने का तो सवाल ही नहीं उठा, right? Because we never observe that. So that will just be equal to the probability that my S will be 0, and my S will be 0 when? Only if my N is 0. So that will be equal, and the probability that my N will be 0 is given to me 0.6. Done. Next, we look at the probability that I will observe the aggregate loss of less than or equal to 1. So, अगर less than or equal to 1 देख रहे हैं तो उसमें 0 आ गया और 1 आ गया, right? So 0 का तो हमको आंसर पता है 0.6, but 1 का नहीं पता है. So ठीक है, 1 का निकालते हैं. So what are the chances that I will observe my S as 1? So I look at here. I only see a 1 here. So my N is 1 and my X is 1. That will be the case when I will observe my S as 1. So these are independent. I multiply them together and I take this probability from here. And the probability that X will be equal to 1 is 0.5. So I get 0.15 and then I add 0.6 plus this derived probability to get 0.75 as the total probability that I will observe my aggregate loss less than or equal to 1. Right. So now if I have to figure out my probability that my S will be less than or equal to 2, I am again rewriting it as the probability that my S will be less than or equal to 1 plus the probability that my S will be 2. Does this make sense?
Yes, ma'am, got it.
You got it? So वही same चीज हम लोग करके हम लोग देख रहे हैं कि कब हमारा S will be 2 and these are the two cases. So यहाँ पर N1 है, X2 है, यहाँ पर N2 है, X1 1 है और X2 1 है. So these two cases, you add them together and you get some answer. And you add this thing together and this thing together. So this thing will come from here 0.75 and you will get some number for this and you will get the total as 0.95. Does this make sense to everyone? Any doubts so far? Okay, anyone want to say something?
I said no now.
Okay, all right. Okay, so let us see the fourth case. Okay, can you all try the fourth case by yourself? Would you all want to try the fourth case? So the fourth case would be the probability that I will observe a S less than or equal to 3. It will just be, the probability that my S is less than or equal to 2 plus the probability that my S will be 3. So this we know to be 0.925. This will be what? How do you guys think I should be writing this?
Probability n is equal to 2, comma, x1 is 2 and x2 is 1.
Yeah.
Plus probability n is equal to 2 where x1 is 1 and x2 is 2, like the opposite.
So yeah, the chance will be same, right? 0.5 square. So I can just write 2 times this.
Yes.
Right? So it will be what? 2 times n equals to 2 is 0.1 and this will be again 0.5 squared. So you'll get some answer for this and finally for this we get 0.975. So do you guys observe something? The numbers are increasing, right? 0.6, then 0.75, 0.95, 0.975. So because we're deriving cumulatives, we have to see to it that these are increasing. If not, then you for sure know that something wrong is going on. right? Okay, so next up we have the fifth case, which is my favorite case. What do you guys think will be the probability that S will be less than or equal to 4?
1.
1 minus probability S less than greater. Oh no, sorry, I was talking about S equal to 4.
Equal to 4? And what about others? What do you guys think?
It will be 1.
Who said
Yeah,
that?
1 itself.
Yeah, right. It will be 1, right? Because every time my S is always less than or equal to 4. So, I mean, you can do this calculation, but you will eventually boil down to 1. So, yeah, that's it. I mean, we have derived the whole distribution for S right then and there. Okay. So, now if we go back to see how can I write this set as? Is it okay to you guys if I write it as the union of all the cases for n with my s being less than or equal to x and my capital N being equal to small n? Do you guys see what I have done there? So basically, if I have to figure out all the claims wherein I have observed my S as less than or equal to X, what I am doing is I'm categorizing this thing on the basis of different N's. So I say that, my total set that my S will be less than or equal to X will consist of the fact that S is less than or equal to X and my N is 0. Then S is less than or equal to X, my N is 1, right? So basically, if you see it in terms of this example, what's happening is the chance that your A is above this line, right? And that it is contained within the sample. Then your B is above the line, C is above the line, E is above the line, D is above the line. So this is what you are adding. And you have this subcategories, 0, 1, 2. So this A can represent, n equals to 0, n equals to 2, n equals to 3, n equals to 4, n equals to 5. And these are the claim amounts. So if, let's say I was figuring out the chance that you will observe more than something. So the probability that I'll observe my S greater than this line will be the fact that this, and this is observed, plus that A is observed, B is observed, and C is observed. So this will be, again, basically I'm just adding all of these cases till my n is infinity and still my x will be less than or equal to x. Do you guys agree with this? Yeah.
Yes, ma'am.
Yes, ma'am.
What about others?
Yes, ma'am.
And rest of you guys?
Yes, ma'am.
Okay, so, do let me know if you haven't understood anything. Okay, so now what I will do is, I will just write, suddenly I'm out of colors. I have so many colors. Okay, so if I have to write my probability that S will be less than or equal to X, given that I'm defining my this set as such, this union will convert to summation n going from 0 till infinity, and I'll write my probability that I'll observe a S less than or equal to X and a capital N equal to small n. Does this make sense? So this is the formula which is of utmost importance to us. So in a way, to solve this question, we guys used this. But this is just how I have to write it in terms of, mathematical notations. Does this make sense to everyone? Hello, am I audible?
Yes, ma'am.
I think my connection went bad. Is everything that we studied up until now clear to everyone?
Yes, ma'am.
What about others?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Thank you very much.
Yes,
So
ma'am.
I think that's all for today, and we'll have our next lecture on Wednesday. Yeah. So I'll just save this. If you guys have any doubts, do let me know. What?
Thank you, ma'am.
Have a great day.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
It was lovely to have you all.
Thank you, ma'am. Ma'am, will you send this recording today itself? I mean,
Yeah,
update.
yeah. I'll upload the recording.
Yes, ma'am. Chapter 12, lecture 12, 12 recording is not uploaded yet.
Oh, it is uploaded, right? If you, I think
Okay.
you guys have to refresh it.
Okay,
वो
I
page
did
में
it.
कभी
I did it, but I'll do it again. I mean, I'll check it. Hello, ma'am. You're not audible, but it's fine, ma'am. I'll check again. Thank you.